Retention occurs when the stereochemistry is preserved through a planar or constrained intermediate pathway, and inversion occurs when the reaction proceeds through an intermediate or transition state that allows attack from the opposite face. So whether you get retention or inversion at an sp2 center depends on the mechanism and the geometry of intermediates and transition states. Think of an sp2 carbon like a flat pancake with molecules able to attack from above or below. If a reaction forms a planar intermediate, such as a trigonal planar carbocation or a carbonyl, then new bonds can form from either face, which can give different stereochemical outcomes, but neighboring groups or catalysts can block one face, so attack happens on the same side and you get retention. Some pathways, like concerted pericyclic additions, have a synchronized motion of electrons that lock in a particular face of approach, so the newly formed stereocenters keep the original arrangement, while stepwise mechanisms with free rotation or lifetime allowing rotation tend to lead to inversion or racemization. Also remember that if an sp2 center becomes sp3 and then reverts, the geometry during the sp3 stage and how substituents rearrange determines whether the original stereochemistry is restored or flipped. A common mistake is assuming that any attack on a planar sp2 center always gives a racemic mixture, when in fact steric hindrance, chiral catalysts, or neighboring group participation often bias attack to one face. So consider those influences to predict retention. Another error is forgetting that some mechanisms are concerted and stereospecific, so they preserve relative stereochemistry, and the tip is to identify whether the reaction is concerted or stepwise before predicting outcome. Students also sometimes overlook that neighboring group participation can temporarily create a bridged intermediate that enforces retention, so look for groups capable of enantiomeric assistance. For more videos and resources on stereochemistry and reaction mechanisms, visit www.gumballdegree.com.